So train data set, test data set, and the labels. Labels means two dependent variables are there. One seasonal vaccine, the other is H1N1 vaccine. is.NA vaccine train come out of two brackets decreasing is equal to true. So you can see there are many missing values in columns. Similarly, sort call sums is.NA vaccine test come out of two brackets decreasing is equal to true. This also has missing values, similar columns. So missing values we have found out. We have to impute them. Install dot packages mice. So mice is a very popular algorithm which can be used for imputing missing values. So install dot packages mice, MIC. Mice means multivariate imputation using chained equations. This is a very powerful algorithm which is there in R, which is being experimental in Python, iterative imputer. So we install the library. Imp is equal to mice, open bracket. Oh, we didn't combine the data. Let us combine the data first. Combine df is equal to rbind, row-wise concatenation, vaccine train, comma, vaccine test. We have combined the data frame into one, row-wise concatenation. Imp is equal to mice, combine df, comma, m is equal to 3, max it is equal to 3. Run it. Shit. We should have given 2. 2 should have been better. Hey, you m is equal to 2, max IT is equal to 2.
So what is the meaning of m equal to 2?
It will do 3 times imputations. Right. And out of the 3 methods, it will give you the first best one with least error.
M means m max IT.
Iterations.
Okay.
M is equal. In help type mice, you'll get the see here. So M is the number of multiple imputations. How many times you want to run the imputation? Default is 5. Method max IT is iterations. See, number of iterations. 5 times, 5 imputations, 5 times. That means 25 times it will do. Generally, because since we have many variables that are missing values, so we are reducing the iterations and the imputations to 3. See, first one it started 1 and 1 it has done. 1, 2 it is doing now. First iteration, first imputation, second iteration. So you can see here 1, 1, 1, 2, 1, 3. Each variable. So mice, what happens is the missing value will be the dependent variable. The missing value column will be dependent variable. Rest of all will be independent variables. And linear regression or logistic regression will run based on the variable type. And then predictions will also happen. That prediction values will be replaced with the missing values. Chained equations. Column wise. The column or the variable that has missing values will be the dependent variable. Independent variable, generally it will be independent variable, right? But it will be made into dependent variable. Like this.
Sir, ఏ values తో ఇంప్యూట్ చేస్తారు సార్?
See, we have missing values in these 3 columns, right? First, it will do mean imputation. First, it will do mean imputation because we can't have missing values, right? So, here we have missing values here and here. It has imputed with mean.
In that column.
In that column. Okay. Now, then it made each the one which is there as NA. Okay. And these 2 variables, it will take it as independent variables. Age will become dependent variable. Age has a missing value, right? Age will become dependent variable. These 2 will be used as independent variables. While linear regression will be built, a predicted value will come in linear regression. That is 35.3, which will be replaced in the case of mean. First, it will do mean imputation for numeric data, mode imputation for categorical data. Then, in the next iteration, it will make that Missing variable column as dependent variable.
Even for
Only that column. One dependent variable only one now. So here it is making the first see. Age it has taken as dependent variable. After imputing age, it will make the income missing value. Now income becomes the dependent variable, age and gender will become the independent variables. And then prediction will happen, a new predicted value will come, 13,103 will be replaced. So this is the iteration. Same here, more imputation will be done. Then this will become a dependent variable. And then logistic regression will run, and then it will impute. This is the process of iteration of chained equations. So it will build multiple equations.
at a time, okay, sir.
Simultaneously it will do. If you look at the process in R, it will do simultaneous equations. See? So in this case, first one is the H1N1 concern will become the dependent variable. In this case, H1N1 knowledge is becoming dependent variable. So it is doing third imputation, first iteration. It is completed. 3 imputations into 3 iterations. So combine div underscore in is equal to complete some error events might come. So in dollar logged events. See here, there is no change. Age group, education, race, These are the variables which we don't want to impute. Sorry. They have been kept as constant. You can see the logged events. Iteration, imputation method is constant. Constant means it didn't do any change there. Right? So in this data, all the variables are categorical in nature. All the variables are categorical in nature. So you can see here, most of the variables are categorical in nature. So we will impute them with as factors. Sorry, we'll convert them into factors. So we convert them back to factors. Now we will split data into train and test. Vaccine train underscore DF is equal to combined DF imp dummy square bracket 1 colon 26,707 comma. Vaccine test underscore DF is equal to combined DF imp dummy square bracket 26,708 colon 53,415 comma. Train DF and test DF. We are splitting them back to train and test. Okay. So we will be split, we have split the data back after pre-processing, we have split the data back to train and test. Now, we are bothered about H1N1 vaccine prediction. H1N1 vaccine prediction is what imbalance data is. So, vaccine train DF underscore H1N1 is equal to data dot frame vaccine train DF comma H1N1 underscore vax is equal to vaccine labels dollar H1N1 underscore vaccine. We are adding the dependent variable to the data frame. We are adding the dependent variable to the data frame. We are adding the dependent variable to the data frame, wherein we found out this is imbalance data. You can take this bottle. Anything is okay. Please for that. Okay. See, this is imbalanced data. You can see here. There are two dependent variables, seasonal vaccine and H1N1 vaccine. There are two dependent variables in our data. Actually, the study focused on two variables. See here. Seasonal vaccine and H1N1 vaccines. Using the same independent variables, you have to build two models. One model to predict seasonal vaccine, the other model to predict H1N1 vaccine. Now, if you look at the seasonal vaccine table, vaccine labels, dollar seasonal vaccine, see, 0 is 14,272, 1 is 12,435. You can see here, right? So there is equal, almost similar representation. This is a balanced data. This is a balanced data. Whereas H1N1 vaccine, there is a big difference between 0 and 1, which is an imbalanced data. So balanced data is where both the classes are represented almost equally, all very close to one another, not equally. But look at this one, this is very bad, right? 21,033 zeros, 5674 ones. This is an imbalanced data. When you do an imbalanced data prediction, this one prediction will be very bad. Zero prediction will be good, but one prediction will be very, very bad. So this will affect our model. In imbalanced data, the model performance will be bad for minority class. Minority class is 1 here, majority class is 0. For H1N1 vaccine, majority class is 0 and minority class is 1. Minority class is 1. When you build a model on imbalanced data, the prediction of minority class will be very bad. The predictive accuracy of minority class will be very bad. So the predictive accuracy of minority class will be very, very bad. So for imbalanced data, we can do oversampling. Oversampling, we can do undersampling, we can do SMOTE, which is synthetic minority oversampling, rows random oversampling techniques. So we have some sampling techniques which can be used to increase the data. So these are algorithms. See, this is what we will do, undersampling or oversampling. Undersampling means from majority class, you will decrease the record, delete the records. Oversampling means you will duplicate or copy the records from minority class and make it equal to majority class. So that we have to do. And SMOTE is synthetic minorities thing which where we will create more artificial data. We will create artificial data in SMOTE. See, between the observations, you create artificial data for the major minority class and try to increase the sample size. Synthetic minority oversampling technique. So, see here. A synthetic data will be created among the actual data. Artificial data will be created.
The data will be taken from existing data.
It will be, calculation will be from existing data. See here. So we have 3 points. 11, 4 observations are there. 11, 12, 13, 14. Okay, and in between it will take a new observation will be x1, x11 plus gap into difference. So a new observation will be taken from here and the gap will be calculated using the Euclidean distance and multiplied with the difference between the two observations. A new observation will be created using this formula. Synthesized rate is R1 is equal to x1 plus gap into difference. Okay, so minority class or sampling, it will create artificial data within the observations using Euclidean distance method. Install.packages rows. Caret also. Okay. So if you look at the imbalance data problem, H1N1 underscore logic is equal to GLM H1N1 underscore vaccine tilde dot comma data is equal to vaccine train DF underscore H1 comma family is equal to binomial. Family is equal to binomial. I will start back. I will in contrast. Why it is coming? For all the variables, manual imputation we can do using if-else statement, which dot max table of X. Okay. Now we don't have any missing values. If you run the previous statement, you will see there are no missing values in our data. So we don't need tidyverse. Because we are doing manual imputation using the if statement, so we don't need tidyverse. Vaccine train underscore DF is equal to combined DF square bracket 1 colon 26,707 comma vaccine test DF is equal to combined DF square bracket 26,708 colon 53,415 comma vaccine train DF H1 is equal to DF dollar H1N1 underscore vaccine is equal to vaccine train DF, sorry, vaccine labels $H1N1 vaccine. Oh, okay. We have to combine here. We have to change. Combined DF is equal to data dot frame combine DF. So add one more line, change the combined DF to data frame after the conversion. $37 variables, huh? Yeah, got it. So what you have to do is, you have to add this line. Before splitting the data, change the data from list to data frame. Because once we run the for loop, this sapply, it will change into a list. I think all the notes also is gone, huh? Okay. So table vaccine train DF $H1N1 vaccine. We got it as 0 and 1, right? Imbalance data. So imbalance data problem. H1N1 underscore logic is equal to GLM steer vaccine train here. So we have to convert them into factors also, right? So add the line here only. Combined DF is equal to L apply combined DF comma as dot factor. Combined DF is equal to data dot frame combined DF. Then we'll split the data. Vaccine train DF dollar H1 underscore N1 vaccine is equal to as dot factor vaccine train DF dollar H1N1 vaccine. So please check the lines from 22 till here. I have combined them into factor also, converted them into factor also. See here, after the conversion, I have also converted them. See, these two lines are very important. Factor conversion. And then I split the data frame. You added these two factor lines before splitting the data frame. Then you can build a model, logistic regression model. Run, all of you. So after this, you build a logistic regression model. H1 N1 underscore logit underscore predict is equal to predict H1 N1 underscore logit comma type is equal to response. H1 N1 logic predict is equal to if else H1 N1 logic predict greater than equal to 0.50 comma 1 comma 0. Library caret confusion matrix as dot factor H1 N1 logic predict comma as dot factor vaccine trained deer dollar H1N1 vaccine comma positive is equal to 1. So you can see here sensitivity is very, very less, 0.48, whereas specificity is 0.9503. Sensitivity is very, very less. From the confusion matrix, you can see sensitivity is very, very less.
ట్రాకింగ్ డేటా చెప్పారు కదా సార్ అప్పుడు. అది R లో లేదు సార్.
Time series, na? We have done it both in R and as well as in Python. So as you can see, sensitivity is very, very less. Okay. So from the output, you can see here, the accuracy overall is 85.12. This is the confusion matrix. Accuracy is 85.12. But if you look at sensitivity, it is 0.4841. Whereas specificity is very high, good. Positive predicted value, negative. Prevalence is less. All these metrics are bad. They should also be more than 0.70. And balanced accuracy is 0.71. Positive class is 1. So you can see here, the imbalanced data is causing this problem. The imbalanced data is causing the problem. So what we will do is library rows. Imbalance data oversampling. Okay. So H1N1 underscore oversample is equal to O1 dot sample H1N1 underscore vaccine till dot comma data is equal to vaccine train underscore DF comma method is equal to over comma n is equal to majority class. How much we have majority class? Yeah, 21,033. So 21,033 into 21,033, how much it will be? 42,066. So n is equal to 42,066 dollar data. Table H1N1 over sample $H1N1 vaccine. Now you can see both of them are 21,033. So we have equal number of zeros and equal number of ones. Duplicating records in minority class and make it equal to majority class. So we have H1N1 over sample. See H1N1 over sample. We got the data in the form of a data frame, 42,066 observations, right? Now we will bear logit underscore over sample is equal to GLM open bracket H1N1 underscore vaccine tilde dot comma data is equal to vaccine train deer square bracket -1 comma family is equal to binomial. Summary logit over sample. We got similar 19,135 only. Oh, sorry, I have given wrong data. This has to be H1N1 over sample. That's why I got same output for the previous model. So AIC is 39,297. You can see here, some of them are significant variables. Okay. Logit underscore over sample underscore predict is equal to predict logit underscore over sample comma type is equal to response. Logit over sample predict is equal to if else greater than equal to 0.50 comma 1 comma 0. Confusion matrix as dot factor logit over sample predict comma as dot factor vaccine over sample H1N1 over sample dollar H1N1 vaccine comma positive is equal to 1. Now you see sensitivity is 77, specificity is 78, oral accuracy is 78.17. In the confusion matrix, you will see there is a difference. Accuracy has come down, but sensitivity and specificity, they are closer to one another. Got it? So if you see the observation of the output, the accuracy has decreased. See, earlier it was 85. Now it came down to 78. But look at these metrics. They are all closer to one another, right? Even balanced accuracy is also 78.17. See, all these metrics are closer to one another. Sensitivity and specificity is almost similar. So we have the balancing of data will help you to predict the minority class also in better way. So we have used in oversampling. Now let us use undersampling. Undersampling is delete records from majority class randomly and make it equal to minority class. So undersampling is where we will delete records from majority class. Okay, so how much we have? If you look at our original data, undersampling, what is the value we have? Five, 6, 7, 4 something, no? Five, 6, 7, 4. Undersample method is equal to under n is equal to 5, 6, 7, 4 into 2, how much? A 4 into 11,348. 11,348. Table H1N1 undersample dollar H1N1 vaccine 5674 5674. So for undersampling, we got AAC of 10,838. See here, 78.15. 4462, 4406, 1268. Under sample. So O1 dot sample method is equal to over, under, and both. Both under sampling and over sampling. Got it? Now there is one more method called rows. This is a synthetic data by random over samplings. So rows is a very interesting thing which is there, which is similar to synthetic minority or sampling technique only. So rows is what we have in here. So we will use rows to predict. So imbalance data, rows or random over sampling synthetic data. By enlarging the features of both majority class and minority class examples. So synthetic data by enlarging this thing. So we can do the rows. So H1N1 underscore rows is equal to rows same formula H1N1 vaccine till dot dollar data table H1N1 underscore rows dollar H1N1 vaccine. See 13,345, 13,362. Logic underscore rows is equal to GLM H1N1 underscore vaccine tilde dot comma data is equal to H1N1 underscore rows square bracket -1 comma family is equal to binomial. Summary, logit underscore rows. Logit underscore rows underscore predict is equal to predict type is equal to response. If else, equal to 0.50, comma 1, comma 0. Confusion matrix so accuracy slightly improved, 78.57.
Last week
Got it? So slight increase in accuracy, but sensitivity, specificity, all are closer to one another.
flow action prediction పంపించారు కదా సార్ మీరు అంటే లాస్ట్ టైం ఇన్స్టెంట్ క్లాసెస్ లో వాటిని డేటా
ఏది
ఫ్లో యాక్షన్ ప్రిడిక్షన్ అని పంపించారు కదా
అవును ఇవాళ షేర్ చేస్తాం కదా ఇప్పుడు మనం వర్క్ చేసేది అదే డేటా మీద కదా ఆ రోజు you would have directly downloaded from the driven data. Website is driven data. See, that day you might have downloaded directly from the website, driven data. It's a hackathon on driven data. Flu vaccine prediction. So SMOTE also is there, DMWR package. See, you can also use SMOTE here, DMWR package. Install.packages DM W small R capital. Oh, DMWR is not available for this version of R. So it's an old library, it's not updated. Let us see if you can find any other. SMOTE family is there. Yes. Train test and labels. Yes. Yeah, maybe that was the case. Okay, we will try SMOTE family. Install.packages SMOTE family. Library SMOTE family. Okay. Then we will use H1N1 underscore SMOTE is equal to SMOTE vaccine trained deer comma minus C 1 comma 36. Huh? Vaccine trained deer dollar H1N1 vaccine. Data non-numeric. Oh, KNN, shit. KNN needs data numeric only. It doesn't work on factors data. So let us see SMOTE. So SMOTE doesn't work on non-numeric data. We have factors data, na? So that is the problem. See, KNN algorithm works only on numeric. That's why we couldn't run the SMOTE earlier also. We use rows. Instead of SMOTE, we use rows in R. In Python, iterative executor. SMOTE is that SMOTE, sorry. In Python, SMOTE is there, na? We have imbalance data. Imbalance, random oversampling, random undersampling, and SMOTE. Where we there in Python we have more SMOTE and SMOTE NC. SMOTE N is for categorical, numerical. SMOTE NC is both numerical and categorical. So SMOTE N, I think we have used na, in Python.
Yes.
For categorical. So that we don't have here in R. So this is your imbalance data in R.